Okay, welcome back to their third video. That's it. This is the reason why I chose to help with math, guys, because my voice didn't make the things to be done. So yeah, we're gonna do. Remember, on the previous video we did the inverse function of a straight line, and the reason why it was so smooth is because a straight line is a one-to-one function. Therefore, its inverse function is also a one-to-one function. Therefore, there's no need to do any restrictions and what's so not on it. So it's a very simple concept. Now with a parabolic function, as I promised that we're gonna do the next one on the next video. This time around, we're gonna do a parabolic one. But before we get into a parabolic function or the inverse of a parabolic function, we have to first do a little bit of revision on grade 10 concept. Remember, guys, you were taught this thing in grade 10. Therefore, this is just going to be a revision to remind you of what is what, and for those who forgot a little, right? But if you didn't necessarily forget, but you don't know or you are blank on this concept, then I will gladly upload a video solely on this concept. Good. So now let's just do a little bit of background information on what functions really are. Or actually, yeah, what are functions? The moment you see functions, we are talking of a function of x, which is basically the y, which is basically y, is equals to, let's say we have 2x squared. It means a value of y can be gotten when x is already provided. So if x is 2, then y would be what? I would say I would substitute 2 onto x. I would have 2 squared. 2 squared is 4. 4 times 2 is 8. Therefore, y would be 8. Right? So that's a function. And if you were to plot this on a Cartesian plane, you would just say where x is 2, you go to 2. Let's say here it's 2, right? Then you go to 8, you go to 8, then you would have a point somewhere above there, right? So this is basically a function. I don't want to go deep into what a function is, the textbook definition or what's so not. Nah, we're not doing that here. So now I want you to understand that there are types of functions. There are functions and there are just graphs which are not functions, but I'm not going to dwell on the aspects of not having functions. I'm just going to talk about functions, the ones that are. So in functions, we have one-to-one functions and we also have many-to-one functions. A one-to-one function is basically, an example is a straight line, right? It's basically a graph or a function where, okay, let's start here. When you say one-to-one, we are talking about one x value versus one y value on each and every point on the graph. So as you're moving along the graph, you realize that we always have a 1 point of x, like one value of x 4 versus one value of y, one value of x versus one value of y, just like that, just like that. So the moment, that's why mostly we tested the type of function using a horizontal line. Like for an example, if I put this pen here, I'll realize that when I move along this pen, there's only 1 point that touches this pen, meaning there's only one x value for one y value, one x value for one y value. Function, we call it a one-to-one function. So a straight line is also a type of a function. Also, the exponential function is a one-to-one function because there will always be one x value versus one y value. But now when you go to parabolic functions or the parabolic graphs, you realize that we have many x values versus one y value. Like for an example here, we can see that on this horizontal line where the line passes through -2 on y, you will realize that we have two x values. So here the x value is -3/2, and here the x value is 3/2, which is positive, but their y values are -2. The y value is the same. So we have two x values versus one y value. Many x values, one y value, many-to-one function, right? So the inverse function of a one-to-one type of function will also be a one-to-one function, because even if you swap, remember when you get an inverse, you are swapping y and x. So if you swap, you will have y, which is still 1, and x, which is still 1. Therefore, it is still a one-to-one function. But the moment you go for the inverse function of many to 1, if you swap this, you will have a 1 here and the many here. Therefore, it will be 1 to many. And based on the grade 10 concept, a 1 to many function is not a function. Therefore, it means the inverse of a parabola is not a function. I don't know if it makes sense. So we're going to draw the inverse of a parabola, but we'll also go for the restricting the domain of the original so that we can make an inverse a function. Clear? So let's first now let's go to grade 12. Now let's find the inverse of a parabola of a parabolic function. If I have an example, I prefer using this example because it's easy and smooth. And if you want us, me and you, to do more complicated questions, you can send them through and I will do them for you or with you. So now, if we have f of x is equals to 2x squared and they want you to determine an inverse of this graph or of this function, remember the first step would be y is equals to 2x squared. Rewrite f of x as y. Then the next step would say inverse y is equals to x. Remember, we are reflecting this graph above this line, something of this kind, where we have y is equals to x. Remember that, right? So now, after writing this, I will swap x and y. I would have x is equals to 2y squared, right? Then I would say, remember, the moment we have x equals to 2y squared, this is an inverse, but always make y the subject of the formula. Therefore, to make y the subject of the formula, I'll have to divide by 2 both sides and introduce a square root to remove the squared. So I will say over 2 over 2, y squared is basically equals to x over 2. Now we'll introduce square root and square root, but now it's going to be plus or minus. Remember, the plus or minus will always be introduced on the side that you are not making the subject of the formula. I'm trying to make my y the subject of the formula here. Therefore, my plus or minus will be on the side that my variable is not the one that I'm trying to make the subject of the formula. So I will be left with y is equals to plus or minus square root of x over 2. So now, that's why this, and it's going to be written like this. Remember, I told you when you represent an inverse function where y is the subject of the formula, you have to show by this to the exponent -1. It's just an inverse symbol. And then you can represent it in an f of x. It's going to be x is equals to plus or minus the square root of x over 2. Now we have the inverse function of this, which is a parabola. So if they say find the inverse function of a parabola, this is it. So this is the one. See? So now it's going to get interesting when we have to draw it. So if I have to draw it, let me draw my Cartesian plane here. A very tiny, cute little Cartesian plane here. This is my origin, this is my x-axis, this is my y-axis. So if I draw the original one, you can see that there's no q, right? If you know how to draw functions, you know that if there's no q and there's no p, it means my p and q are o, which is the origin, which means my turning point will be here. And my a is positive, then it's going to smile. So it's going to look like this. It's going to look like this. See? So now I will just test a point, just one point. To make it a bit more fun, I can test with 2. If I have a 2 here, I will substitute 2 here onto x to get the corresponding y value. I will say 2 squared is 4, 4 times 2 is 8, which means here it's going to be 8. Then this coordinate will just be 2 and 8. Always do that. Test one point. You can even use 1. You can substitute 1 on x so that you can get the corresponding y value and write that coordinate for the coordinates of that point, just to show how spread the graph is. Right now, I will determine the inverse. If I have to draw the inverse, which is this one, I know it's a bit tricky or a bit challenging to draw a graph of a square root of something, right? So in order not to learn how to draw a surd function, just take this one and swap every y with x and with every x with y. For an example, I'm going to start with this point here. I have 2 and 8, so which means the inverse function will have a point 8 and 2. So I will look for 8 on x somewhere here, and I will look for 2 of y somewhere here, and I will say there's a point here, right? And remember, the origin had coordinates 0 and 0. So even if you swap 0 and 0, it's still going to be 0 and 0. Therefore, my turning point will also still be here, right? So this graph was going to the positive of y. You see it's above the x-axis, meaning it's on the positive of y values. But now it's going to be on the positive of what? If it's not y, the inverse will be of x. Therefore, it's going to be on the positive of x this way. Doesn't make sense? So my graph will look like this. Easy, ne? So now you have the point. This one, the coordinate will be 8 and 2. And you have your O here. So the inverse function of a parabola, this one will be your f, and this one will be your inverse. So this is not a function, because when you use a vertical line test, you would see that we have many y values versus one x value. When if you draw a line here, you would see that with this one x value, you have different y values, which means you have what? One x value to many y values. One to many is not a function, right? So that's where now it leads us to restricting a domain of the original so that we can make an inverse a function. So when you restrict a domain of the original, we are looking at the turning point. The turning point. It's either I'm going to take this side only, because now it's a one-to-one function if I'm only taking this side, or I can take this side only. So if I'm only taking this side, I'm cutting this graph into two halves. So I'm only going to take one half, because one half will make this part of the graph a one-to-one function. And remember, an inverse of a one-to-one function is basically a function as well. So if I'm taking this one, I would say on my original, right, I'm doing what? On my original function, I'm restricting the domain and say x is only greater and equals to 0 on my original, right? Which if I'm taking this part, guys, if I'm taking this part, I would say x is greater than 0 and equals to, because this part has only the positive x values. Therefore, x is greater than 0. If I'm restricting it and taking this part, I would say on the original, x is less than equals to 0. So if I'm only taking this one, it means if I draw it, it's going to be like something like this. If I draw this, the graph of f of x is equals to 2x squared, where x is only greater than 0, the graph will look like this, where you still have your 2 and 8 point, right? So its inverse will have the domain being the range, because on x I will substitute by y. Remember, when you move from original to inverse, where you see x you put y. In everything, where you see x you put y, and where you saw y you put x. So which means on my inverse I will say what? Y is the one that is greater than 0, and my inverse function is basically what? If my y is 0, is greater than 0, it means it's positive. On that inverse, I will no longer consider the negative, but I will only take the positive, because now it's greater than 0. Our y values are positive, which means the inverse is only positive now, which means I'm only going to take positive square root of x over 2. If I were to take where x is less than equals to If I were to take where x is less than equals to 0, on the inverse it will be y is less than equals to 0. Therefore, the inverse function would be what? Would be negative square root of x over 2. It would be negative only. But now I'm not doing this one. I'm only doing this one. You can also do this one on your own. So now that you have this one, if I were to draw the inverse function of a parabola with no plus or minus, but just plus or just minus, I will look at this one. With this one is a plus, so I will look at this point and I will say this point still existed, right? So which means its inverse will be 8 and 2, right? Which is going to be here, which is going to be 8 and 2. Now it was the first point, which is 0, where it was the turning point, will also be 0, or 0 and 0, which was also the turning point for the inverse. But now it was going on the positive y. Positive y. The original was going on the positive y, which means the inverse will go to the positive x. Positive x on this side. So it's going to look like this. So when you look at this, it's also a one-to-one function. Therefore, the inverse of this is now a function. So when you look at this, remember I told you that the original and the inverse will always intersect at x equals to y. So if I draw my mirror line, it will go like this. They intersected here. Here is y equals to x. This one is the inverse, and this one is the original. Even here, they intersected there, you see? X equals to y. So there we go, guys. This is how you draw the inverse function of a parabola. Also by restricting the domain so that the inverse of the parabola can be a function as well. I hope this was helpful. And if you need me to do any extra explanation on something that I missed on this video, you can just holler back, comment, inbox, DM. Yeah, you get it.